So, have you ever wondered why Google Chrome all of a sudden is eating all your memory? Like, you've got a couple of tabs open or whatever, but why is it taking all of your memory? Like, literally all of the memory is being taken by Google Chrome in here. I know a lot of you guys have faced this issue, as so many other people, and it could just be because you have actually opened like too many tabs, or it could be because the website you're accessing have pretty bad memory leaks. So this is how memory leaks could go wrong. So for example, this is a very bad memory leak in here caused by a simple counter application put in React where you can increment either A, B, or increment both. And if you look into the memory usage, the first snapshot before I increased the count in here was 120 megabytes only. And the second snapshot in here, after incrementing it like a couple, like to 80 or something, it got to 6 gigabytes, from 120 megabytes to 6,000 megabytes, 6 gigabytes. And a 58 big object instances that were not freed from memory, which is a huge memory leak. So I've been going through Twitter recently and I actually saw this really interesting post made by Jake about memory leaks, and he put like a blog post in here explaining how closures are bad in JavaScript and how they could easily cause memory leaks. So I was wondering, how could I not know about this before? So actually the blog post he put together, it's a really nice blog post that goes into the details of how closures work, why closures are bad, and how you can easily shoot yourself on the foot with a pretty bad memory leak in JavaScript. So I really was to go ahead and actually read through this blog post, because I'm not like, all the credits go to Jake in here and the other guys who have made other blog posts in here. For example, the Sneaky React memory leak in here, which is a really awesome blog post that explains memory leaks in React using, the new memoization, use callbacks and stuff. We're going to explain this in a second, but of course, all the credits goes to the blog post in here. Both of these blog posts, including the other blog post, that is the Grokking V8 in here from 2012 that has been explaining how closures could be pretty bad and can cause catastrophic memory leaks in here in JavaScript. So I really advise to go and actually read through this 3 blog posts. I'm going to leave link description below. But I wanted to make the video in here just to explain a few stuff in here and go through this step by step. And apparently this issue has been there since 2013. Like, this is when the bug was submitted on the Chromium forum in here for like the first bug for closures. There's been so much activity since like July 31st, 2024, and it's still not fixed just yet. It's still a bug that exists in Chromium and pretty much in any other browser, like the Mozilla one in here 11 years ago that has been like this bug open, and the WebKit in here, or Safari, it has that one since 2021. So literally every single browser has this issue, and mostly the browsers that run V8 engine, which is Chromium based browsers. So let's go through this very simple example here that was introduced by Jake on his example on his blog post in there. So first, what is a closure? So if you're not familiar with like what closures are in JavaScript, you are just a little ignorance, because I'm pretty sure you've used closures at least once in your life in JavaScript in here or React or whatever. It's just like a function in here, like it's creating here this callback that we pass into the set timeouts. So any function that you define inside of another function, so this is actually the parent function, the demo function, and we've got this set timeouts, we declare inside of it a callback. So this function in here, when it references a variable in here from the outer scope, for example, the big object in here is from the parent scope of this specific function right over here. That means we call this function a closure because it references or accesses variables from the outer scope of this current function. So as simple as that, this is basically what a closure is. It's a really good feature in JavaScript, but of course it has this really small issue in memory leaks. It's useful pretty much in everywhere, like callbacks, asynchronous code, in React. Like, we've used it pretty much everywhere. And JavaScript is just so good with this. So let's go through why closures could be really bad, and if you're not careful with them, you could just literally shoot yourself on the foot and have a pretty bad memory leak in your JavaScript application. So let's take, for example, this demo function in here that we already have. So instead of a demo function here, we're just doing a simple console log. Next, we are actually initializing a very big object. This big object is the class above in here, which is we're just initializing this data variable that is, we're doing new, we're assigning this an unassigned integer array basically, and we're putting inside of this 100 megabytes of data, which means we're reserving 100 megabytes in memory pretty much. So that's what we're doing, just like for testing purposes. Obviously we've got the big objects in here that is initialized out of the scope of function. That's cool. The next thing in here we do set timeout, and we've got this callback that gonna be running after 1 second. And later on, all we simply do is just going to return a new function. We're not calling this function, but we're just returning the reference of this new created function. All you do when you call this function is going to clear out the timeout. That's it. I mean, this program could be looking very innocent, right? It just looks very simple, nothing big of a deal. You would assume that, oh, I initialized this, I reserved 100 megabytes of data. That's cool, but obviously, as we all know, that the garbage collector, the JavaScript garbage collector, or the VA's garbage collector, that as soon as this function scope ends, like as soon as this function did run and it finishes running, we assume that this big object is going to be freed from memory. Like the garbage collector is going to take care of that, it's going to remove it from memory, we don't need it anymore. Well, you're wrong. JavaScript says otherwise because of this stupid closure in here that actually going to cause a lot of issues. So to properly understand this, I'm going to jump into the DevTools in here. I've got the application running here, just a simple JavaScript application that says hello. And I'm jumping to the memory tab for the profiling so I can check how much memory this current application is basically using. So right now, if I go ahead and do start a profile, or take a snapshot, it has 170 megabytes. If I'm going to go look into the constructor, I'm going to find my big objects. So this is actually what we're looking for because that's basically the object that has all the data, has 100 megabytes of data. So if you look into this, this is the class or the constructor. So the big object in here, and this is like the instances, like how many instances this class object has inside the memory. The more we're gonna find in here, the worse. That means you've got a memory leak. So right now, so far so good, right? We got one big object. It doesn't seem very bad. It has 100 megabytes. Yeah, that's fine. It's not really that bad. But we shouldn't be having these objects because the demo in here is like, it should run, it should return the function. The demo has finished running, so we no longer need this big object thing. It should be freed from memory, right? Well, that's wrong because we've got this reference pointing to this specific function in here that could be called at any time. So the cancel demo in here is just basically like a reference to this function that we can call any time. So because we've got this function in here, that means it could be called any time. The big object on top of here is never garbage collected. It never freed from memory because the scope in here is always retained. And it stays inside of memory because the program thinks, oh, this function can be called anytime. That means this function could access the outer scope or the closure of this particular function in here, which means we're going to keep this in memory just in case, right? And that's just going to keep this in memory. So if I'm going to try to call the demo, let's say I'm going to call the demo and put in the variable, demo 2, demo 3, 4, maybe 5, 6. I'm going to do 10 demos in here, which means I'm going to call this function 10 times. I'm going to initialize this big object 10 times. And of course, as we've seen before with the one function in here, it's going to be retained inside of memory. The scope is never going to be freed or removed. And thus, everything in here is going to live in memory. So I'm going to have 10 objects inside of memory. So this is actually our first snapshot. To take another snapshot, I'm going to go ahead and click on this one. You're going to notice it jumped from 117 megabytes to 1 gigabyte, like 1061 megabytes. And if you look at the big object constructor in here, we've got 10 instances of that inside of memory, and all of them, this is all of them in here. Each instance is going to be 100 megs. And that's a simple definition of a memory leak. But imagine we comment all of this, but we go back to this global this. And by the way, if you're not familiar with the global this, just basically putting a variable on the global scope, all the program can basically access that variable. So here I'm going to do the console demo. Remember, we've already initialized this with this, but right now I'm going to put the console demo to reference undefined. So it's going to equal undefined. That means this demo reference is no longer going to be there. So let's see how that reacts. So I'm going to go back in here. I'm going to refresh, of course, just to make sure the program is running perfectly. So I'm going to go ahead and take another snapshot in here. And now it jumped from 1 gigabyte to 14 megabytes. And if you try to look for the big objects instance in here or inside of the memory, it doesn't exist because it was garbage collected, and that's what it's supposed to do. There's no memory leak now because there's no references. All right, let's try to go through another example. So the same thing in here, we've got another big object that takes 100 megabytes of space or memory, and we just simply initialize it in here inside of a demo. But now we're not doing set timeouts. All we're simply doing is just creating 2 closures or 2 inner functions. We've got inner function 1 that all it does just create this simple function, and it does a console log, but it references the big object from the outer scope, like from the parent's function scope. the big object.data.length. All it does, it just prints that out. For the inner function too, like the second inner function, it literally has no reference. It's not referencing anything related to the big object. All it's doing just like printing static text, like hello from inner function too. So you assume that this is not a closure, right? Because it's not referencing something from the outer scope. So we shouldn't call this a closure. And as you might think, that this inner function too is harmless and should not cause any issues. Now, this specific example is going to show the dumb part of the JavaScript engine. So let's see, or go to the memory snapshot. So remember, we're just running this once. We've got only one big object, so they expect in here because we have a memory leak. Why? We've got this global this. We're putting the inner function in here, like we're putting this closure to the outer scope in here, and it references something. That means the whole scope in here is not going to be removed from the memory. That means it's going to retain this big object inside of memory, and that's going to cause a memory leak for sure. So if we go back in here, I'm going to take a snapshot, and yes, I'm expecting a memory leak. So I go look into the big object is there. That means we've got a memory leak. So it has one instance as expected. That's fine. And if you try to look at the objects, like where it's located, you tell it that it's being retained by this inner function. This is actually where the context in here is retained. It's inside the inner function. All right, cool. That's completely fine. Now, we would assume that if we go ahead and do this, like right after calling the demo, we go ahead and do global this.inner function equals undefined. That means we completely remove the references of the inner function. That means it no longer has a reference to this closure. And that means the outer scope in here, or the scope of this function, including the big object in here, are going to be completely removed from memory. So that's what you would expect, right? Because this inner function is the only one that's actually referencing this big object, and the second function is not referencing that one. Yeah, probably. That's what I thought too, before this mind-blowing dumb example in here. So if I go back in here, I'm going to do another snapshot and make sure I'm going to go and refresh. So do another snapshot in here, and that's basically going to have the same memory, 120 megabytes. If I'm looking at the second snapshot, I still got the big object inside of my memory. If I look into it, one instance. If I look into it, it's still referenced inside of the inner function too. I mean, how could the big objects be referenced inside of inner function too? Like, how could be the context? I mean, by the context, I mean the scope could be referenced inside of inner function too. That makes completely no sense. But yes, my friends, that's the dumb part of JavaScript. So even though this function has nothing to do with referencing any variables from the outer scope in here, basically has no connection with that, but still JavaScript is taking this as something that references the other one. And because now this is still referencing this specific closure in here, it's not undefined like the inner function one, JavaScript thinks, oh, I'm going to keep this outer scope for a little longer. And that's still going to cause the memory leak. But now if we go ahead and do inner function, we go ahead and reference that to undefined. That means we completely remove the reference to this closure in here. So we can finally go ahead and free this closure from here. I'm going to go ahead and do the snapshot again. And now it became 15 megabytes and there's no big object retained in memory anymore. And of course, this has been really, really well explained by Jake in his blog post in here. So I really go and advise you guys to go ahead and check it out. I'm going to leave a link in the description below. The second most interesting one that I found mind-blowing as well when it comes to React, because I've been doing this for quite some time and I never noticed, or I would rather say I never looked or expected this specific thing to do memory leaks or cause memory leaks, which is the use callback in here and using closures inside of your React component. And of course, we use closures inside of React component all the time. So again, if you want a detailed guide of how everything works interconnected, the examples and everything, I advise you guys to go and look into this blog post. It's really, really great. It enlightened me in so many information about React and memory leaks. So I'm going to just go through and actually copy a couple of examples from this blog post. All right, so here we've got a simple component. I'm calling this original memory leak because this component has or causes a memory leak. Same thing that we did before. We've got a big object in here that has a constructor. All it does just puts 100 megabytes or reserves 100 megabytes in memory. And we got two states in here for counter, like counter A and counter B. We initialize that big object. If you can notice one mistake already, that would be great. If not, the mistake is pretty simple. You should never initiate or create new objects in the body of a React component here. You should never do that because React re-renders and he runs this body multiple times and you never want to initiate or create multiple instances. That's pretty bad already. But this is not the topic of this issue. This is not the cause of a memory leak. And second, we're creating two handlers, handle click A and handle click B. Both of them are using use callback for memorization, and both of them have this callback in here. The first one is going to just increase the count A, and we're going to create a brand new callback every single time count A is going to change. I mean, you think that's pretty good, right? I mean, that's something I would do personally. Just do count A in here. If count A changes, just go and create a new callback with the new value of count A. Simple, easy peasy. The same thing for click B in here. We're just doing use callback again. And we've got another closure, but this time it's not using the use callback, but it's just like a normal function closure that we're calling it handle click both. It has handle click A, handle click B, and all it does is just console logs the big data in here, which means it references the big data or the big object we have outside. So since this one is referenced right inside of this closure right over here, that means this big data object is going to be retained inside of the context or inside of the scope that these three functions in here are going to have access to. All right, pretty cool. So this is used back just for knowing when component has mounted and unmounted. And we simply here just do an increment A, increment B, and increment both. And we just like displaying the count A and the count B. So we've got the application here. We didn't do any increments or actions or anything just yet. So first I'm going to take an initial snapshot in here just to see the state. We've got 120 megabytes. If I'm going to look into the data that's already there, because the component has been rendered once, we've got only one instance of the big object inside of the memory, which is completely fine. That's how it should work. That's good. But now I'm going to go and try to increment A, increment B, just going to try a couple of stuff in here. Just keep incrementing, maybe just 7, A7, B7. I'm going to take another snapshot. Wow, from 120 megabytes to a 1587 megabytes, which is a 1 gigabyte and a half. And yes, if you haven't seen that already, Big Object has 15 instances stored inside of the memory. Well, we only need one instance, right? We don't need this 15 instances. This is clearly a memory leak, a very, very bad one. And if you just never look into the profiler or look into the memory usage, you may think, oh, this is a very innocent React application that only does just increment A, increment B, displays the counter for you. Oh, that's pretty cool, right? But no, this is pure evil. And yeah, if I keep incrementing in here, like increment B, increment A, just keep going, smashing this. I don't know, like you can try me. I've got like a 64 gigs in my Mac in here, so I'm not worried, but don't do that if you have a very limited number of RAM. So I'm going to go and try and take another snapshot, and it's 2.5 gigabytes already with a 25 big object instances. And you can imagine if you've got a big application like this and each part has a small memory leak, it could blow up in front of the users and you don't even know what happened. So yes, memory leaks are pretty bad and can eat up memory super fast. And if we take a look like the actual context of the scope, if you click one of the instances, so first instance in here, big objects, it's not like a deep down, but look at this. This big data in here has been referenced out of handle click A, handle click B, and it just keeps going. Like this is where it's being referenced currently, like the context. And that's really a huge bug. So this has been really greatly like explained in this blog post with all the demonstrations and stuff, and especially this really awesome explanation of exactly what happened on step by step with this really awesome diagram. So I advise you go and look into this for better understanding, because it basically like explained it perfectly. But I'll just quickly explain what happened in a very quick way in here. So imagine this is basically the component that has the memory leak, right? So we got the big objects in here, we got account A, account B. So this is like the current scope. So every single time you create a closure, as we said before, the closure will go ahead and have a reference of the outer scope in here. So depending on the variables you access, for example, on this one, we're accessing count A. So the count A in here is going to be added to the context that's going to be shared by this function. Second, this function is having count B. Count B is going to be added to the previous counter, the previous context that already had count A, which means right now inside of that context, we're going to have count A and count B both referenced and retained. And last but not least, we got handle click both in here. It only accessing the big data and also accessing these two functions. That means this function is going to be added to the context as well. The other B function is going to be added to the context as well. And the big data is going to be added to the context. So now inside of the context, we've got count A, count B, handle click A, handle click B, and the big data objects. Pretty nasty context. So as explained in here really well with these diagrams in here, like you got this initial render scope in here. So the handle click B in here is going to have it. If you click on handle click A, B is going to still have a reference to their previous app scope 0, and it just keeps going. So like every single scope, like app scope 1 or app scope 2, is going to have a reference to the previous scope, which means none of these scopes are going to be removed or destroyed or completely freed from memory. They're always going to be retrained inside of memory, and you just keep creating new scopes, new variables, and a new big data every single time you put 10 megabytes or 100 megabytes, for example, in our case, and it just keeps going, and it gets worse and worse and worse. So as he explained in here, the general problem that the different use callback hooks in a single component might reference each other and other expensive data through the closure scope. The closures are then held in memory until the use callback hooks are recreated. Having more than one use callback hook in a component makes it super hard to reason about what's being held in memory and what's being released. Remember, having more than one use callback could cause this disaster. And the more callbacks you have, the more likely it is that you will encounter this specific issue. Well, how you can avoid this? Just keep your closure scope as small as possible. Avoid capturing other closures, especially in memoized ones like inside of use callback, or if you're using use memo. And you can use like an escape hatch, the use ref in here, to basically manage like large objects, like the big objects we had before. And yes, just recently saw this new article in here about the sneaky React memory leaks in closures versus React query. So apparently React query actually can cause memory leaks as well because it uses closures. So anything that uses closures is vulnerable to memory leaks. Anyway, so thank you guys for watching. Hope you guys loved this tutorial video because I wanted to share something that I didn't know before and I just knew about this, which is pretty great. So anyway guys, thank you guys for watching. I just want to share with you like this really mind-blowing thing that could happen in JavaScript that I didn't know about before, and pretty much a lot of you, I'm sure, don't know about this. That's why I wanted to put this video together to explain to you guys how things can go wrong in JavaScript with closures and also in React. Because as you all know, I'm a React lover and I'm pretty much sure you are too. So anyway guys, thank you guys for watching. Hope you guys enjoyed and catch you all hopefully in the next ones.